Class, today I'm going to help you fill in the real number system graphic organizer. And if you take a look, it looks like it's broken up into two parts. On the left side you have rational numbers. So let's go ahead and just put a line right here to separate. So on the left side, and actually maybe let's just put a big box around here. So on the left side you have rational numbers. And then on the right side, you have irrational numbers. So I'm going to put a box around that too. And you can do the same thing on your graphic organizer. So real numbers are split into two parts. You've got rational numbers. And on the rational number side, underneath rational numbers, you have integers, you have whole numbers, and you have natural numbers. And all those are considered rational numbers. And then on the other side you have irrational numbers. So let's first talk about rational numbers. So if you take a minute, fill in the boxes like I have, and then we'll give definitions and we'll give examples. So hit pause right now, complete the left side with all the titles that I have, and then once you're ready, hit play and we'll fill in the definitions and give some examples. Okay, so add this to your graphic organizer. The definition of a rational number is any number that can be expressed as a fraction. And as you know, fractions can be converted into decimals. And when they're converted to decimals, they're going to either be a terminating or a repeating decimal. So some examples of rational numbers would be a fraction like 1/2. So if you have 1/2, you know that can be changed or converted into a terminating decimal like 0.5. Or perhaps you could have a fraction like 2/3. 2/3 can be converted into a repeating decimal like 0.6 repeating. Other examples of rational numbers could be 0.75 or 0.31 repeating. So basically we're talking about any fraction or repeating decimal or terminating decimal. In addition to fractions and decimals, integers are also included under rational numbers. So let's take a second and we'll add the definition of integers to our graphic organizer. Okay, so here's the definition of an integer. An integer is the set of whole numbers and their opposites. So, for example, I'm going to write this on the side here. Integers would be any negative number, so like -3, -2, -1. 0 also is an integer, and then the opposites. So opposite of -1 is 1, opposite of -2 is 2, opposite of -3 is 3, and this could go on and on. So we could have gone back to -4, -5, -6, and so on, and then the opposites. So integers are basically all whole numbers, negatives, positives, and 0. So let's talk next about what is a whole number. So basically a whole number starts at 0 and it's just going to go up from there, and it's just going to be a whole number. So whole numbers are 0, 1, 2, 3, 4, so on and so on. So let's go ahead and get that definition into our graphic organizers. Okay, so whole numbers are basically 0, 1, 2, 3, 4, 5 into infinity. So it's just going to keep going and going. They're whole numbers, they're not decimals. So basically what I've written there is what you want to add into your graphic organizer. So the next thing we want to talk about is natural numbers. And natural numbers, a definition for them is just a counting number. So we're going to go ahead and get that into our graphic organizer. So natural numbers are just counting numbers, and we always start with 1. So counting numbers would just be 1, 1, 2, 3, 4, continuing on into infinity. So on the left side of this graphic organizer, all of these are considered rational numbers. Every single one of these can be turned into a fraction. And at this point you might be thinking to yourself, well, how can a whole number be turned into a fraction? Well, remember, you can put any whole number over 1. So I could put 7, that's a whole number. If I put it over 1, that's a fraction. I could take -3, that's an integer, but I could turn it into fraction by just putting it over 1. So everything you see on the left side of this graphic organizer is considered a rational number. So now let's turn our attention to the right side. What is an irrational number? So we'll go ahead and get that definition into our graphic organizer. So irrational numbers, so if rational numbers can be expressed as a fraction, then irrational numbers cannot be expressed as a fraction. They are non-terminating and non-repeating decimals. So the most famous example of an irrational number is pi. And pi is a non-terminating, non-repeating decimal. It is approximately 3.1415926. It just keeps going on and on. It doesn't terminate. There's no repetition to it. So that is an irrational number. Another example of an irrational number would be the square root of 2. And if you put that in your calculator, you'll see that that is a non-terminating, non-repeating decimal. So you'll see that it just keeps going on and on. It doesn't end, and there's no repetition to it whatsoever. Another example of an irrational number would be something like square root of 10. So non-perfect squares, we've been talking about perfect squares recently. Non-perfect squares would all be considered irrational numbers. So anything that's non-perfect, like square root of 2, square root of 10, those would be considered irrational numbers. So let's go ahead and add that to the irrational side of our graphic organizer. Okay, so I added to the irrational side the square root of any non-perfect square. So square root of 2, square root of 3, square root of 5, anything that's not a perfect square. If you try to take the square root of it, you will get an irrational number because it will be a non-terminating, non-repeating decimal. So if non-perfect squares are irrational, that must mean that perfect squares are rational. So over on our rational side, we can go ahead and add like the square root of 25. So the square root of 25 is 5 and -5, and those are both rational numbers. The square root of 4, that's a rational number. So any perfect square is going to be in the rational side. Non-perfect squares will be on the irrational side. So let's go ahead and add that to our rational side. Okay, so I went ahead and added perfect squares down here to the bottom. So perfect squares would be considered rational numbers because they become whole numbers or integers, positive and negative. And non-perfect squares, like square root of 2, square root of 10, square root of 7, anything like that, would be considered irrational. So hopefully this helped. Make sure that you glue this into your spiral notebook so you can refer back to it at any time that you need to. And if you have any questions, please let us know. Thank you so much for listening.